Chapter 1.2, Day 2, Vertical and Horizontal Translation. So first we are going to discuss horizontal translation. The graph of f of x minus h is a horizontal translation of the graph of fx. When you have the graph that is absolute value x, the parent graph for this function would be starting from 0, 0 up 1 over 1, or you can say that 0, 0, 1, 1, 2, 2, 3, 3, and so on and so forth. So for the graph f of x minus h, you're moving the graph h units right. So for example, if h is 2, then you're going to move this graph 2 units to the right side, and that would be your graph, moving the graph h unit to the right side. And if you have f of x plus h, then you're going to move the graph h units left side, so h unit left. And for example, if you have h as 2, then you're going to move this 2 units to the right, and going to follow the pattern that is up 1 over 1 and make a graph. Now let's talk about the graph that is vertical translation of the graph. The graph of fx plus k. If the k is outside of the function, then we use it for vertical translation. And we are taking the same parent graph fx equals absolute value x. And if you have fx plus k, then you're going to move the graph k units up. So we're going to move k units up. Let's say k unit, if it's 2, then we're going to move 2 units up. And then when you have k as a negative, so we're going to move this graph as k unit down. So let's say if the k is 2, then we're going to move the k unit down, which means we're moving k or 2 units down. And for the definition, it said that fx plus k, then the graph shifts upward. If it is fx minus k, the graph shifts down. Let's do the example number 1 at the bottom here. So for letter A, for example number 1, writing translation of function. Let's say the function is absolute value. Write a function h whose graph is translation 2 units to the left of the graph. And then the 2 unit left of the graph will look like absolute value x plus 2. It means 2 is inside the absolute value, so 2 is inside the parallel lines. So for letter B here, write a function g whose graph is translation 3 units down of the graph of fx equals absolute value x. If it is up or down, then we are going to write the number outside of the function. So it's going to be x minus absolute value x minus 3. It's going to be negative 3 outside of the 2 parallel lines, that is this one. So x absolute value x minus 3. So for letter C, write a function h whose graph is translation 9 units to the right of the graph of fx absolute value x. So if it is right or left, we are going to use the number inside. And if it is right, we're going to use negative 9 inside. So the function hx would be absolute value x minus 9. For letter D here, write a function g whose graph is translation 7 units up. Any function that we are going to translate up or down, we use this number outside of the 2 parallel lines. So if it is positive, we're going to use positive 7. And if it's negative, we're going to use negative number outside of the parallel lines. So for number or letter E and letter F, you're going to use the parent function as the given function. So fx is absolute value x plus 3 is our parent function in this case. So we are going to make changes in this function right here. What changes we're going to make is that the translation is 5 unit to the left. We're going to make a new function. I wrote accidentally a g here. It should be hx function, and we are going to make changes on the function here. So it's already plus 3 in between the function. When we are going to move this again to the left side, which means that we are going to add 5 inside. So when we add 5 with 3, it's going to be x plus 8. So the new function hx is going to be x plus 8. For letter F, write a function g whose graph is translation 11 units down. Whenever we're going to use up or down, we are going to add or subtract on the outside of the function. So for this case, we're going to negative 11 outside of the function. We have already 2 outside, and when we are moving this graph 11 unit down, then we are going to subtract 11 outside of the function, and then the final answer would be absolute value x 2 minus 11, which is 9. So this absolute value x minus 9 would be our final answer. Let's do the reflection, that is the bottom section of the graph. Reflection of the graph. So reflection in the x-axis. The graph of y equals negative of fx is a reflection in x-axis of the graph of y equals fx. So for example, if you take the function that is absolute value x, and the graph of absolute value x is 0, 0, 1, 1, 2, 2, 3, 3, 0, 0, negative 1, 1, negative 2, 2, and negative 3, comma 3. If you multiply the outputs mean y value, by negative 1 changes their signs, then is going to be your reflection graph. So the parent graph have these type of points. So negative 1 comma 1, 0 comma 0, and 1 comma 1. And when we multiply the y coordinate, that is this point right here, with the negative 1, then we are going to get a flip graph. So let's make a flip graph or a reflection graph here. So we multiplied all the y coordinate by negative 1. So this was 1. We multiplied it by negative 1. We got negative 1. We multiplied the 0 by negative 1. We got 0. And we multiplied this one with the negative 1. And we got negative 1 on the last point. And now we are going to plot these points. When we plot these points on the graph, we get negative 1 comma negative 1 is this point, 0 comma 0 is this one, and 1 comma negative 1 is this point. Now we can connect these points, and that's it. That is going to be your reflection graph, where you're going to multiply all the outputs or all the y values by negative 1 to get the reflection graph over the x-axis. The next section is reflection in the y-axis. So the graph of y equals f of negative of x is a reflection in the y-axis of the graph of y equals fx. Let's take a parent graph as a square root function this time, that is square root of x, and the parent graph of the square root graph is 0, 0, 1, 1, and so on. So when you connect the point, you're going to get the graph like this, and this is a square root function graph. Now we are going to get the graph that is a reflection over the y-axis. For this, we are going to multiply all the x values by negative 1. So our original point for this graph is 0, 0, 1, 1, 4, comma 2. And now we are going to get the points that are reflected points for the y-axis, and those points are, when you're going to get 0 comma 0, multiply the x coordinate by negative 1. So it's going to be, this point is negative 1 comma 1, and then the last one is negative 4 comma 2. Now we are going to plot these points, and these points are 0 comma 0, negative 1 comma 1, and negative 4 comma 2, and that would be your reflection graph over the y-axis, where you multiply all the x coordinate by -1.